But a customer could call in and buy a pump and say, I want this, and I want that, and I want this, and I want that. A whole bunch of different specs, and we can basically do it all.
Yeah. They can call in and say, they don't even have to pick a brand. They can just say, I need a pump to do this amount of flow, this amount of pressure, this kind of a control at this range. And then, okay, what kind of budget are you looking at? What kind of application is it? Okay, we can do it in a Linde, we can do it in a Parker, we can do it in this, we can do it that way.
Hey, welcome back. This video is on the Linde product line, which is a hydraulic pump made in Germany. Lifco is the largest stock and distributor of Linde in the world, and we are the largest Linde distributor, so stocking or non-stocking, in the Americas. It's something that we do very well, and Lloyd's one of the best at it. So let's hear him talk about doing a conversion on this one from what we have in stock to what the customer needs so that it can ship within 8 hours as opposed to the 80 days that it would normally take from the factory.
This is an HPV135 Linde, the O2 series. The customer ordered a left hand, we have a right hand.
The other one didn't have that filter.
No, the other one had, they call it filter eliminator block. So you can put this filter on. This is the reinforced filter. There's also a standard filter. Depends on what you want.
So why do you always test it like that?
Oh, these you have to make sure that when I switch to port plates have to be the exact same size or within the Linde spec. Depending on the generation, there could be a couple of thou difference. So if this one is X and this one's Y, I have to reshim my barrel to make sure it accommodates. Because if it's too much preload, it'll burn it out. If there's not enough preload, have excessive case leakage, pump will not work right.
And even though you ordered it straight from Linde, like, it doesn't matter?
No, because it could be a generation thing. We don't know when this one was built, when they used the parts from.
Fair.
So, they're the same. But it's a lot easier to measure it, check it, then put it on the bench, have it fail, take it apart, redo it all.
The thing again with the lube tubes?
Yep.
And in a span of 2 days, how many Lindes have you worked on here? Or a week, maybe I'll even say.
Depends on the week.
Yeah. I mean, I know of 2 because I filmed this one and yesterday's.
On Monday I did a double HPR, so I don't know if you want to count that as
Is
one
it
or
Linde?
2. Yeah.
Oh, double. So then 2. They're a tandem?
Yeah.
You take that off in order to put it back on?
I don't have to take it off to put it back on. This is the heavy duty reinforced filter. Handles a higher PSI. Customer doesn't specify that they want that one.
Got it.
So I'm gonna put a different one on it. So if I just put it over here, I won't ding it or damage it when I'm putting it up.
Yep.
And it makes it lighter.
And it's awkward.
Yeah, and the 135s are about as high as I want to start lifting it anymore.
Same torque spec?
Nope, these are M12, so they're 140 foot-pounds. M14 bolts, sorry. Not 100, not M12. M12, M14. gotta love when it stops at 137 foot-pounds. It's gotta go to 140, right? So you run out of room right here, it's 133.
And that, yeah.
And then you gotta start over.
And we're not changing the control?
I'm not changing the control out completely, but we are changing the control range from it. So this one is 4 to 10. Customer wants 4 to 16.
And that would give them what? More CCs?
No, so it's the same amount of CCs, but it's control range. So you have, so one's 4 to 10 bar, the other one's 4 to 16 bar.
So smaller increments going up then?
So you have a 6 bar from min to max,
Yeah.
or you have a 12 bar range from min to max. Just gives you more control, like a longer amount of control.
Yes.
So if you want to feather something.
Okay. Trying to think like what application that would be.
Say you're using it for a drill head or something. If you want to drill some stuff, you want to drill at 300 RPM. Other stuff you want to drill at 1200 RPM.
Yeah.
So you might want to feather it, the range between there.
Yeah.
If you've got a smaller range, it's going to go from slow to fast in that range, or from slow to fast in that range. Just gives you more of a command range.
Okay, so he's talking about resolution, an important concept in hydraulic controls. We listed some of the ranges. What he has is a closed loop Linde pump, and it's a hydraulic control. The hydraulic control means that if he gives 4 bars or less, then the pump will be off. And if he gives the high end of the control, then the pump will be fully on. In this case here, 16 bar. This means that how precise they want the flow rate to be depends on this range. For instance, let's say they had it where it was 0 and 1 bar. It would essentially turn the pump into full flow or no flow, and it'd be very difficult to get anything in between there. You cannot precisely work with a half a bar, a quarter of a bar of pressure on here. Remember, each bar is 14 psi? Hydraulics isn't that precise with the pressures. Now, how this all came about is that the original winches were 0 to 5 bar. And that means they had a joystick. And so when the operator pushed forward on the joystick would allow some of the pressure through to then signal to the pump. It meant that even if the joystick wore out just a bit, this entire system would no longer be proportional, meaning that it could go anywhere on here. It would essentially just turn it to either here or fully on. The Lindes have currently, they got a 2 to 8 bar spring, a 4 to 10, and a 4 to 16. Why do they have these? It's because the ability of a joystick to provide that level of control. Each one of these is a newer generation of joystick. 40, 50 years ago, they had 0 to 5 bar, which was essentially useless. The 2 to 8 is quite poor. The 4 to 10 is about the same. And then the 4 to 16, though, is sufficient to get the level of control that's required for most applications.
So it's just a spring?
Yep, and there's not a big difference between them.
Oh, you would think the thickness of
It is the thickness that changes it. So this is like a 3.2 mil, and these are like 3.6. When they're that close, I like to double check because everybody makes mistakes. Yeah, because by turning this in or out, it either puts more tension or less tension on the spring, and then your pressure on the spring changes it. So then when we put it on the bench, we have to make sure that our beginner control is going to be correct, because you can adjust your beginner control by moving this large circle in and out.
Now, the beginner control sounded really fancy. It actually isn't. So you saw the clip about resolution, and the resolution was talking about this control that said you want to turn the pump on, start to turn the pump on at 4 bar, and finish turning the pump on at 16 bar, meaning it's fully on. So 4 would be at 0%, and 16 would be at 100% of flow. The beginner control says that the 0% is actually at 4 bar. Remember, it's just a spring, and the spring could have different tension in it based on the temperature of the room. So we want to actually calibrate it to say, turn the pump on at 4 bar. And that's the begin of control.
So this could be it could be set perfect right there.
Yeah.
Or I might be out. I won't know until I test it.
Test. The parameters are given by the customer or just by the model?
That's given by the model code.
And a customer would do that?
A customer could if they wanted, or they could specify what they wanted. We would do it. So on the other one, we had a POR valve. So we had to set it to POR 80% of the crossover relief. So the crossover reliefs, if it's set for 5,000, the pump will go to 5,000 and compensate, basically. So just dump to the other side. So you can have, that's like a safety valve. So if you want to run at 400 bar, you can put these in at 420 bar. So then your system relief will relief at 400 bar. And if it fails, this is there as a safety.
Got it.
I'm a big believer in having backups in a system because I've had hoses blow up on me, so it's not fun. So there's not a big difference between the two. The way you can tell is by the end cap here.
And that's just like the standard one.
Yeah.
But a customer should call in and buy a pump and say, I want this, and I want that, and I want this, and I want that. A whole bunch of different specs, and we can basically do it all.
Yeah. They can call in and say, they don't even have to pick a brand. They can just say, I need a pump to do this amount of flow, this amount of pressure, this kind of a control at this range. And then, okay, what kind of budget are you looking at? What kind of application is it? Okay, we can do it in a Linde, we can do it in a Parker, we can do it in this, we can do it that way, and that's it.
Okay.
Now we test it, make sure the beginning control is right, that the flow is going to hold, that everything was assembled right, back end's not going to leak, charge pump doesn't fall off, stuff like that.